Alright, so we're going to be dealing with a problem today that is quite different from the ones we've done so far on electrostatics. And the problem is on the board. It says two tiny balls, each of mass 1.52 milligrams, are suspended from a common point by a light insulating thread 20 centimeters long. Okay? Now, if they are assumed to be point charges of equal value that repelled each other until each makes an angle of 15 degrees with the vertical, calculate the charge on each. Now, this problem is quite technical and it requires you drawing a free body diagram on what you're having here so that we can work out the problem. Okay, so that's what I'm going to do first. So the solution to this first is drawing out a free body diagram, and here is what we're going to have. Okay, we're going to have something like this. Now, it says two tiny balls, each of mass 1.5 milligram, okay, are suspended from a common point. So if the common point is here, in which they are suspended from, okay, by a light insulating thread. Now, here is the key feature you should take note of. This insulating thread simply means that the thread does not conduct electricity, that is, charges cannot bleed through that thread that is used to what now? To hold the spheres or the tiny balls, okay? And then it is 20 centimeters long. Remember that will be converted to meter. Okay, so I'm going to write it here. 20 centimeter, which is 0.2 meter for the length of the thread. Okay, and if they are assumed to be point charge of equal value, now it means that if the charge on ball 1 is Q1, okay, if the charge on ball 1 is Q1, it is equal to the charge on the ball 2, which is Q2. Okay, the question also says, if they are assumed to be point charges of equal value that repelled, that is, they moved away from each other, okay, until each makes an angle of 15 degrees with the vertical. Okay, so I'm going to come here to complete the diagram. Both balls repelled, that is, they moved away from each other. Okay, if you don't know what repels means, I think you should watch an introduction to electrostatics, which is our first video that talked about the basics of electrostatics, okay, and the laws of electrostatics as well. So if they are repelling, simply means they are what? Like charges. They are either positive and positive or negative and negative. Okay, so we're going to assume these are the two balls and they are repelling each other. So this one will move away with a force, and this one as well is going to move away with a force. Okay, now the question further said that they repelled until each made an angle of 15 degrees with the vertical. Each. So if we're having a vertical line here, okay, we're having 15 degrees and we're having 15 degrees as well. Okay, each of them is making an angle 15 degrees with the vertical. The question then went further to say we should calculate the charge on each ball. That's what it simply asked. They did not ask us to calculate if it is a positive or a negative charge, but we do know that both of them have to be what now? Like charge. That is either positive and positive, negative and negative. Okay, so to do that, we are going to work on this free body diagram. Of course, these balls, the two balls, they have a mass of 1.5 milligram each. So we do know that the weight is going to act downward. Okay, weight, which is mg, is going to act downward, okay, for both balls. And how about the distance of separation? Okay, let's say the distance between these two balls, the distance of separation, let us call it r, of which we know from our previous video that given the Coulomb's law, the distance of separation between two charges will also affect the force of attraction or repulsion. Okay, so we're having r as the distance between these two charges. So if from here to here, that is the total distance, okay, if the total distance is given as r, it simply means from one ball to the center, we're going to have half of the distance, which is r over 2, and then r over 2. Okay, and then the length of the string was given as 0.2 meter. Okay, also we do know that this string, they are suspended from a point and there is a weight attached, which means there's going to be tension acting in this direction on the string. Okay, so I think from the question given, we've succeeded in bringing out the free body diagram. This is a free body diagram, that is something we've drawn out of a real diagram or from a given problem. Okay, now to find the charge on each ball, okay, here's the trick to find the charge on each ball. You don't have to count the procedure. Okay, what you need to take note of is that these two balls are repelling, that is, they are moving away from each other. That is what is going on. Okay, and since they are moving away from each other, there is a force of repulsion between both of them, right? There is a force of repulsion. And since there is a force of repulsion, we can use that force to calculate for the charge. Okay, remember F is equal to KQ1 Q2 from our first video, which is on Coulomb's law. KQ1 Q2 divided by R squared. We can use the force that is being gotten to find the value of what now? Q. But how then do we get the value of the force? To get the value of the force, we make use of some equilibrium equations or some form of equilibrium and geometry to get the force. Okay, now to do that, first things first, I want to bring out one of this diagram. Okay, let's bring out one of the diagram, this triangle to the left. So if I bring out the triangle to the left, this is what I'm going to obtain. I'm going to have a triangle with an angle here of 15 degrees. Okay, first things first, let's get the value of r, okay, which is quite important in the formula as well. Let's get the value of r. Now to get the value of r, since r is a distance or length, any other distance we are going to, or any other value we are going to use here must be in terms of distance or length as well. I cannot use force here and then use distance here. I cannot use distance here and use force. It has to be the same distance, or a force, and a force. Okay, that's what I'm going to do. So from here to here is r over 2. Okay, we already said it's r over 2. Now here to here is given as the length of the string, which was given as 0.2 in meters. Okay, so we have 0.2. So it is important for us to find the value of r. Okay, now to find the value of r here, we can make use of our trigonometrical formulas, which is SOHCAHTOA. Okay, so we have SOHCAHTOA. This is just a quick reminder. If you don't know how to solve problems on trigonometry, I also advise you to go back to our video on trigonometry. We also have one, and you can learn from that. Okay, now we're having a hypotenuse and then we're having an opposite in this case. So how then do we find the value of r? Which one connects hypotenuse and opposite? So we have hypotenuse, we have opposite, so we'll see that it is what now? Sine. This simply means that what now? Sine of the angle we are having here, sine 15 degrees, is equal to opposite over hypotenuse. So we have opposite here, which is r over 2, over hypotenuse is 0.2. So from here we can make r the subject of the formula. First things first, cross multiply. We're going to have r over 2 is equal to 0.2 times sine 15 degrees. And from here, r is equal to 2 times 0.2 sine of 15 degrees. Now, can solve for the value of r. Okay, let's solve for the value of r. So to do that, that will be 2 times 0.2 sine 15 degrees. What are we going to get? We're going to get a value of 0.1035. Okay, 0.1035. I'm going to put this in meter. Okay, so we just approximated the value for r, okay, in meter to 4 decimal places. So the value of r is in 4 decimal places. Now succeeded to getting the value of r. Okay, what next are we going to find? Remember the formula from Coulomb's law is F is equal to K times Q1 times Q2 divided by R squared. Now we've gotten R. Okay, what next is for us to find the force, and then we can solve for what now? For Q. Now to find the force, we're still going to go back to this diagram. Remember initially I said that to solve for r, we need to make use of distance or choose. So we have to make use of what now? The distance or the length of the thread, and then to solve for r. Now the next thing I want to find is the force of repulsion. Okay, this force. Okay, I'm going to designate it here as what now? F. So that's what I want to find next. To do that, we have to bring out this diagram again. Okay, so if I should bring out this diagram this time, now using the laws of equilibrium, any force that is acting down is going to equal the force that is acting up for this thing to be in equilibrium. Okay, you can see it's balanced. So mg is acting down, which is the weight, is also going to both now acting up. We're having a line of force here, and we're having a line of force here vertically. So the force here equals the force here. So if I'm having mg going down, I'll also come to this vertical part, and I'll have what now? Mg as well. Okay, now this horizontal this slant part, which is the hypotenuse, remains t. So I'm going to have t there. And then the force you are looking for is acting horizontally. So the force here is what now? Horizontal. So I'm going to come here and I'll write what now? F. Mind you, you can make use of any side of the triangle. I can choose to make use of the left side. I can choose to make use of the right side. I'm going to get what now? The same thing. Okay? Now the angle remains 15 degrees. 15 degrees. Okay? So now, what we are solving for is the value of F. We do not know the value of T. We know how to find tension. We could find it, but then we don't need it. So why then are we going to try solving for it? Okay, we can as well find the value of mg because we are given the mass as 1.5 milligrams. Okay, we can find the value of what now? Mg, and then use it to find the value of F. Following similar process, we can as well find the value of F by using sine, okay, using the same SOHCAHTOA. So we can say sine 15 degrees, okay, or I think in this case we're going to make use of tan because we don't want to solve for t, like I said, okay, we do not want to solve for t. And since we do not want to solve for t, we're just going to come here and make use of these two sides. Okay, so following this similar process, like I said, TOA represents tan opposite over adjacent, and here is the opposite, here is the adjacent. So we can just come here and simply say tan of the angle, which is 15 degrees, is equal to the opposite. Opposite is F divided by the adjacent. So from here, F is equal to mg tan of 15 degrees, okay? And then m was giving us 1.5 milligram. Remember to put it in what now? Grams, okay? Because we are having milli here, and milli is 10 to the power of minus 3. So we're going to have 1.52 times 10 to the power of minus 3. And then the value of gravity. Take note, the value of gravity varies from around 9.8 to 10. So make sure you are using the one given in the question. In this case, 9.8. So I'm going to have times 9.8 tan of 15 degrees. Okay, so from there we're going to have the value of F. Now what will be the value of F? I'm simply going to make the calculator. 1.51, we're going to have 1.52 times 10 to the power of minus 3, okay, times 9.8 tan 15 degrees. Now it's going to give us a value of 3.991 times 10 to the power of minus 3. So we have 3 points. Okay, we're going to have 3.991 times 10 to the power of minus 3 newtons. Now we are not done. We simply just found the force. Okay, we simply just found the force that is going to be used to calculate for the value of Q. Now since Q1 equals to Q2, we can simply equate them to Q. Okay, so that when we multiply Q1 and Q2, we get what now? Q squared. So I'm going to come here and do the finishing of the whole stuff. Okay, so from here we see that F is equal to K times Q1 and Q2 are equal to Q. So we're going to have Q times Q divided by R squared. So F is equal to KQ squared. Okay, KQ squared over R squared. Now this is a very useful formula. So our advice to take note of is this one. It's simply used when both charges have equal magnitude. Okay, so we want to make Q the subject, and to make Q the subject, we're going to have Q equals FR squared divided by K. Okay, Q squared, and then Q is equal to the square root of FR squared over K. So Q is equal to the square root of, now we found the force to be 3.991 times 10 to the power of minus 3. So we have 3.991 times 10 to the power of minus 3 times, what was the value of R? It was 0.1035. So we had 0.1035, okay, all squared, divided by K has a value of 9.0 times 10 to the power of 9. Now K has a fixed value. I talked about how we can always derive the value for K in our first video. So that is also something you might want to look up. Okay, now solving the final answer, we have the square root of 3.991 times 10 to the power of minus 3, okay, times 0.1035 squared, okay, divided by 9.0 times 10 to the power of 9. Okay, it's going to give us a value for Q of Q is equal to 6.89 times 10 to the power of minus 8 coulombs. That's the value of, that's the unit for calculating electric charge. Okay, electric charge will be measured in coulombs. So we're having C here, which is charge. Okay, we could as well write this in terms of some laws of indices, that is by eliminating these exponents and 10 to the power of minus 8. Okay, now seeing 10 to the power of minus 8, I know that it's close to what we call nano. Okay, nano, that's small letter n. Now nano is 10 to the power of minus 9. Okay, having that in mind, nano is 10 to the power of minus 9. Okay, so put this guy in terms of nano. I'm going to divide what I'm having here by 10 to the power of minus 9. And when I do that, I'm going to get Q is equal to, dividing this by 10 to the power of minus 9, we have 9 minus 8, that's 1. So I'm multiplying this by 10. Okay, so I'm going to have 68.9 nanocoulombs. Okay, now this is the value of the charge. I could as well leave it like this or this, depending on the option given to you in the examination. Okay, so that is how a problem like this is being done. What you might want to do at this point is go through the examples again and watch more of our videos to gain more understanding on electrostatics and how to solve problems. So in our next video, we're still going to be talking about some free exercises or some full problems on electrostatics. Do wait to subscribe, click on the notification bell, so that when any of these videos are being uploaded, you are going to be one of the first few persons that will get notified, and then you can learn with ease from any of these. Okay, so see you in the next video. Stay tuned.